Awesome. Then I would say let's get started. Um, Welcome everyone. Today is the November 19th, 2025, the seventh EIP 7928 breakout call. We have quite a packed agenda today, I see, because some of us are in at DevConnect, as you see on the video, and we've been discussing for the past hour everything related to block club access lists, and we put all those things on the agenda. So feel free to have a look at the agenda. I would say we can directly start with the first topic, which is the first topic is actually just a summary of what was decided last week. So last week we discussed if we should add the gas used values into the block access list, and we decided against it, basically because things stay way simpler if we just assume clients order transactions by the transaction index in the block. But I just wanted to put it on the agenda so that we flag this again. And yeah, does anyone have different opinions this week that you want to share? If that's not the case, I think we can just assume we will not put the gas used values into the block live access list and keep it as is. Perfect. Then let's keep it as is. The second agenda item is syncing and pulse. So I would be interesting to hear from client teams what their strategies are when it comes to syncing, especially which block level access lists will we be able to just drop, and how many should we keep around at least? And I'm curious what client teams think about this.
I can say for Geth that we haven't discussed this very much internally outside of the fact that we do see Vals being useful for removing the healing phase of the snap sync. I guess my thinking right now is that probably we will just keep as many Vals as we have blocks for, but that it's probably a good idea to, and also that I do think it should be optional to serve the BALs for historical blocks because like it's optional to serve like the snap protocol. And then yeah, I guess my thinking is that we just have to decide what the window what like a suggested window would be to maintain them. Um, yeah.
Why it will not be necessary to serve a certain block, a certain amount of block, and this amount will be mandatory. Just like that, we'll be sure that for SnapSync, we'll have the recent block, so it should help every time.
Yeah, I mean, it could be mandatory, right? But if you think about like the snap protocol as it currently is, it's not, at least to my understanding, it's not mandatory that a node serves the snap protocol if it's like
Ah,
it's
I mean,
also
if
optional.
if you serve Snap, you should also serve block access list. I was thinking maybe about something like that, but
Yeah, I think the snap protocol would become obsolete. Like this would be the serving the BAL would be kind of like a replacement for snap, but
I'm not sure because we have different steps in Snap. So we have the first step where we are downloading the leaf and we are reconstructing the tree. So I think this step is still mandatory. And after we have the heal, when we are trying to heal the tree and maybe the flat DB if you have flat DB. So
yeah,
for me we can
yeah,
maybe
sorry.
reduce the heal, but yeah.
Yeah, you're right. Yeah, I agree.
I also had a
I think I
discussion
agree
with
with you that it would be mandatory to serve the snap and the BALs. Yeah.
I had also a discussion with Guillaume. He said that maybe if we have a reorg during the snap sync, we will still maybe need a heal because block access list is just it's not bidirectional. We don't have the previous data. We only have the post data, so we cannot roll back a block access list. So if you have a reorg, maybe we'll have to do a heal. But in the happy pass, normally block access list will be enough.
Yeah, Dragon.
I talked with Red Team about persisting balls, and the feedback that I got is the best case for it would be to not persist it at all and not even serve it on over P2P. That will simplest solution to us. If ball is kind of needed for the snap sync, maybe adding, I think Jared proposed this to have a snap sync endpoint that will basically fetch ball bar the block hash. Would probably work.
But block access list in the block header, we have the block access list hash. So how we can verify the hash if we don't have the block access list, which the only possibility will be to replace the block and generate it?
In general, you receive the ball from the engine. I would assume that's the point where we check if this hash is correct or not. But if we drop the balls from the history, I think that hash is going to be there unchecked. I think that could be fine. Because you're basically syncing from the top tip to the bottom and verify all the hashes there.
Okay. So just to summarize, Jared was saying you were planning to keep the bars around and you make it optional for serving for historical blocks. And Dragon was just saying he would prefer to drop them and not serve them at all, or at least keep a few of them around. Am I correct? With a few, I mean enough for SnapSync.
Yeah, I think the team said that they're fine with dropping them all, but I'm not that familiar with that part of the code, so I'm just like transmitting the message that I received.
Okay. Yeah, this sounds like we would want to keep at least enough block club access lists around for like the week subjectivity period. So like, am I correct here? Like 2 weeks of block club access lists? Is that what is like needed in the worst case?
Can you expand on the rationale for that?
Like what is the point in the past when you would start snapsing?
Oh, yeah, I don't know. I mean, I guess it kind of depends on what after you download the entire initial state, like how long the amount of time that you would keep the balls around for would depend on like how long it would take to download the initial like state snapshot, and how
I
far
think
you would be behind. So it's kind of, yeah, like I mean, it's dependent on the however fast the given node can sync.
I think in general it's less than a day. But,
Yeah, 2 weeks would be a long time.
yeah.
Okay, perfect. Any other client has with an opinion on that?
Isn't it normally sort of 64 blocks or around there? Because otherwise you stop getting responses from, you need to be quite close to the head to start it. So a 2-week period would be fair enough.
Okay, this is good because this is then way less data than I initially expected. Yeah, I think it's good that we have discussed it already. Maybe we can also bring it up in 2 weeks for the next breakout call, just to confirm that again. And yeah, use the time in between to look into this more carefully. Perfect. Then let's just move on with the next agenda item, which is block level access list metrics and tracer. So basically, it would be great if we had the metrics that Katja proposed a few weeks ago, if we can get them as early into the protocol as possible. So best case that we have them in definite zero already. Curious what clients think about this. So how far are we on those metrics? Have you already looked into this? I assume this means no. Yeah, I'm not sure in terms of priorities what we should do here. If we should get the metrics already in definite zero, or if we want to focus on having clients running smoothly on definite zero without the metric set, and we're fine with that. And on a related note, I think Felipe had a proposal for including the block live access list in the logs, just as Ref does right now. Felipe, do you want to expand on that?
Yeah, I can expand a little bit. Right now, debugging is quite tough, and so I think that if in debug logs we for block level access list mismatches, if we can get the BALs logged, it would help significantly on the testing side. And so this is more just of an ask to try to get those as debug logs, because right now for a lot of clients we just have the hash mismatch when it's invalid. Yeah, and that makes things significantly difficult to find the issues. So
Yeah, just as Penny says here in the chat, I'm relaying that, putting the whole diff into the log and not just the hash mismatch. That would be great. Perfect. Then just to summarize those 2 points, I guess we're sorry, Mario.
So when you say diffs only, it's you still print the full block level access list only when diffs happen, or do you mean that we should only print the diff of the block level access list against the expectation, or could you expand on that?
Only print the diff, so print the things that are missing in the access list found, and print the things that are excessive in the access list constructed, right? So don't print everything, because access list can be huge and diffs can be like 1 or 2 addresses.
sure. I think then the log should be very clear, like which one has the diff, right? Whether it's the test vector or the client, because sometimes that's not clear. So as long as we agree on that. And yeah, I think the diffs make the most sense for sure.
Perfect. Thank you very much. Then let me quickly summarize that. So we will likely not have the metrics in the depth at 0, but we will definitely try to put the diffs into the logs as soon as possible, just to make testing and stuff easy. Great. Okay, sorry, let me quickly read the chat. What do we do if the order is different? Yeah, this is a good point. Do you have an idea, Lukas?
I would have to think about it. Is the order important?
Yeah, it is important because we of course enforce some ordering, but yeah, I'm thinking, is it that important to have that in the logs? Because if we have the diff anyway, the problem might not be in the ordering, right? So I assume there will not be a bug in the ordering.
Generate a different hash today.
Can't we just
If the
have a
ordering is
generic,
different.
if the ordering is different, can't we just have a generic error message in the logs and it like you don't really need the BAL diff won't even be necessary if that is the source of the error.
Right, yeah. Yeah, that's my feeling too. That if the ordering is wrong, we might be fine with just having a special message there. And for all other issues with the bar, we will include the diff in the log.
The ordering itself could be part of it. Let's say we expect a certain order and this is the given order. So it can be formatted like that.
Perfect. Is there anything else we should discuss regarding making life for testers easier? Is there anything else, Mario or Philippe, that you could think of that we might need? Stefan was just saying any updates on including generated block access list in the debug bad block call. Does anyone have insights there?
I made some progress for implementing it in Geth. And I mean, I can definitely see why it's useful, but it also kind of makes the code path a bit convoluted because now when we are executing and we receive some error from a transaction, we can't just immediately stop executing the block and terminate. We have to like execute every single transaction and reconstruct the block access list, and it just creates it makes an already complex code path just like a bit more difficult to reason about. So I didn't finish implementing it yet. I mean, it can definitely be done, but it's like we haven't on the Geth side, there hasn't been that much like review on the code yet, so it's like adding another piece of complexity on an already significant change to the execution and state root calculation path, but you know. But that being said, I mean, I only spent like a day on it, so there's maybe I'm overstating how invasive it would be, but this is just my impression from having done a bit of like cursory investigation into it.
Has someone else from other client teams already worked on that?
On Bezu side, we have it. So should be okay.
Awesome. Anyone else?
From red side, we're executing all the sections and recreating the ball and just comparing it at the end. So we will not fail if... No, we'll fail if we fetch something that's not existing in the ball, but we will not fail if the change is different than expected. So there is some cases where we maybe could know beforehand, but we would check it at the end of the block.
So the question is, are you providing an endpoint for the get bad blocks and including the generated block access list that you generated in this endpoint as well, so that we can use it for debugging?
It would be easy to add. It's just executing and recreating the ball, but I'm not sure if we have the endpoint for the bad block.
Would be great if you could get back to me on that.
Yeah, this would be great. Maybe would be great if Stefan, if you could drop a message in the bottom access list Discord, just that we have it somewhere written there, so that we can refer clients to that message then. Someone from Nethermind who can give an update on that topic?
I don't know the status. Lucas?
No, sorry,
No
I
worry.
don't know. Mark is the only one that has the newest knowledge. He's working on it, but I don't see him on the call.
Okay, yeah, no worry. Anything else regarding things we might wanna have for testing that we should discuss today?
Just say that the last testing feature is really great. It fixes all the bugs, so it's perfect.
Yeah, it looks like Ref is quite far when it comes to testing. We can directly go into the client updates. So how are other clients doing when it comes to testing with the latest release?
Yeah, I've been mostly working on the performance side, so I haven't been working on the getting conformance with the tests in the latest release yet, but it's on my list.
So on Bezu's side, we fixed several issues thanks to the new test, but there are still some issue in the test suite, so we'll see with the new version. We have a first version of the stateful computation in background that is working, but we are trying to do some improvement on it. And we are starting to work on the perfect parallelization using BAL. It's all.
Thank you very much.
From red side, here on the tests, I think one is failing, but 40 faulty ones were fixed. Yeah, that's mostly it.
someone from Aragon here? I don't think so. Let's continue on with Nethermind, or should we, or do you want to wait until Martin will, or Mark will provide the update? Or do you, Ben, or Lukas, do you have insights into? Okay, I just saw thumbs up. Perfect. Yeah, there is this one topic that has been a recurring theme over the last months, basically, about the read locations or the state locations in the BAL. And the latest I've heard so far was client teams very much were for including the read locations because it enables parallel I/O. And this is the question, like, how would we best test it? I know that Lukas has suggested that we just tested an actual client implementation. So for example, on Kurtosis or something. Is this something that other clients think might be the best thing to do to actually determine if it's worth adding the state locations? Because of course they add a lot of data to the block. It's like 50% of the file size comes from the read locations, the state locations that are not changed. And we have been discussing it in a bunch of Breakout calls, but we haven't really gotten to benchmarks that were like super clear when it came to adding the state locations. And especially we have to think about higher gas limits, like beyond 100 million. And if it makes still sense when we are at those high limits to have the state locations, or if the value of having the state locations in the BALs is kind of declining over time with an increasing gas limit.
So that's a very good question, and exactly we can do different things. We can blindly add state locations. We can blindly exclude them. We could try to implement kind of both and benchmark it on different versions and different kind of blocks. We can then the last thing, we can always try to be smart, and by smart I mean do something like include them conditionally, right? So by conditionally, I mean we could have some heuristic, and that heuristic is that if the transaction does at least n reads, right, or something, then you include them, otherwise you don't, right? So there is way different strategies to target different cases. I think we should be aware about the size increase. So generally, I'm a bit hesitant about including them blindly. But on the other hand, if there is an edge case transaction that does a huge amount of reads, and okay, with 16 million gas limit, it's still bounded, so it's not that bad as without it. But even then, maybe there's some threshold where it's worth including. So we can do multiple things, and depends how much precise in tackling bottlenecks we want to be.
Mm-hmm. Yeah, my concern with having like heuristics for the reads is the following. It's like, imagine disk IO becomes a bottleneck, then the worst case block would not only be worst case in terms of having a lot of S loads, but also having additional data in the block. So it's basically like for blocks that are already like very bad to execute, we would be like, okay, let's add additional data to exactly those blocks. And the blocks that are lightweight will probably not have the read values in them. You know, it's like, it feels almost like counterproductive to be like, okay, our heaviest block will now also include additional data.
By heaviest, by network transmission size? That's what you mean, or
no? By just workload for I/O, for example. Assuming, for example, a block that has only S loads.
Okay, but that block now is can those slots can be parallelized, right? Like completely. At least
Right,
for the
yeah.
worst transactions. So actually, we kind of alleviate the IO bottleneck here by including the reads for those. So my expectation would be the opposite, that we actually have the worst blocks. That let's say we have I don't know what gas limit are we targeting, 300. Okay, 300 gas limit. So 300 divided by 16, that's around 19 transactions worst. And if they are all doing loads, so we could, paralyze that. The networking is the bad thing, right? That we get hit by this huge increase in balls. So I don't know. It's hard to say without the numbers. It's hard to say without benchmarking. It's hard to say without additional complexity of clients that will hit us here and there. But yeah, I think like in most cases we don't need read balls. So they would be just an overhead for networking and block propagation. But here and there might be a transaction that we will say, oh, now this transaction, all transactions are finished in few milliseconds, and this one transaction now tails for next 100 milliseconds. And if we had balls for it, read balls for it, it would just be 10 times less. So that's my guess. But without measuring it, it's hard to say.
One kind of objection I have to the current read slots is they don't, the read locations is they don't have what transaction they're read in. So they're all just lexicographically ordered, which is the equivalent of like a random load. So you can't overlap the running of transactions with the IO. You can't say, all right, I've loaded the data for the first 10 transactions, so I can start running them now, while I'm still loading the data for the following, 100 transactions. Because you don't know what data you're reading. Obviously, there's a size concern going back into the.
Yeah, that's true. I mean, this is in general something we can discuss also alongside having the state locations in the files, if it would make sense to add transaction indices. Of course, the problem here is as soon as we add transaction indices, we cannot aggregate them as well as we can today. Because today, if we have a write to any storage slot, no matter in which transaction index, we don't include that write as a read anymore. Of course, if we would now add transaction indices to reads, which are not needed for a parallel execution, then we would have to kind of deduplicate those entries, and you would have the same storage slot as a write and a read with potentially different transaction indices. So my expectation would be that the block level access list would definitely grow in size by
If we assume that you parallelize transactions in order, so the first transaction you run is the first transaction, and the second transaction, the second transaction, even if it's happening at the same time, is the second one. Then you could achieve the same effect by just marking the first transaction that slot was read in, not every transaction that was read in. So you just need to say, oh, right, this is read in transaction 1. This is the first time it's read, transaction 1, transaction 50 or whatever. And then you'd have enough to start scheduling. You wouldn't need to record, this is read by transaction 1, 5, 10, 11.
Yeah, so exactly. So if we had write first and then read, we don't need to include the read one. And if we had read first and write later, then yeah, we would have duplication, but we again wouldn't have to only once, right? So only one duplication. We don't have to mark reads for subsequent transactions, like only the first occurrence of a read in a block.
Yeah, this makes sense. Then I guess the question is this worth the complexity? I guess this might also depend on the numbers we are looking for, right? So with numbers, I mean the benchmarks that we might still need to get, yeah. Because of course this would be like a worst case that imagine we have a transaction that is at the very end of the block and also scheduled to be executed at the very end of the block, but the prefetcher starts prefetching the storage slot of that transaction first because they are lexigraphically first. And then we would end up with execution not having the cache ready to be consumed.
I think it'll become more of leaving a lot on the table as the blocks get bigger, as the slots get shorter. So it's whether you know, we want to do a Bell's 3-2 or whether we do it.
Yeah, I totally agree. But this is definitely my only concern would be complexity here. Like, will we find like this rule that you and Lukas suggested that if there was a write with a lower transaction index, then the read would just not be included at all, like we do today. We don't include it if there is a write. And then, like, if there is a read with a higher transaction index, with a lower transaction index, then we would actually include the read with the index, kind of telling the client this is something that needs to be prefetched right at the beginning. So what do clients think about complexity here?
I also think if they're in the same transaction, so you do an S load first and then you do an S store later in that same transaction, that would only need to be the read because that would only need to be the write because the read is implied. So it would only be if it was a read in a earlier transaction that had no write. Hopefully that shouldn't necessarily add too much duplication. I don't know how much overlapping there would be on exact block.
We could
Yeah,
also
this is a
wait
good
for some
point.
data to.
Yeah, go ahead.
We could also wait for some data to come in. I think every client would have their own niche parallelization strategy, and we could see like what part of execution is idling on IO. And once we have more data, this would also vary a lot based on gas limit, right? So we could see like where are we putting the limits for execution idling, and then maybe for lower gas limit, maybe under 100, we may not even need it now. So we could just add the complexity as we go later.
Yeah, I can see that point, but I think like we should definitely design the system to work like to be like future proof. For example, ready to support like 300, 500 million gas and so on. So this is like why it's so difficult right now to tell those things because we have no experience with such high gas limits. And as Ben says, the read indices, so having transaction indices mapped to the reads might be becoming more important with increasing gas limits because of course the worst case would then just be a transaction at the very end and the prefetcher starts prefetching everything that is read in that transaction, although it's only needed at the very end of the block.
I agree. Yeah, we should target like getting numbers for at least 300 million. And we could also see if we can like optimize our parallelization strategy to work around this. And only the last resort would be to add more complexity to that.
Right. Yeah. Yeah, I guess at least from the spec side, if I think about the specs, this shouldn't be too complex because this would be a change that is quite isolated in the block access list builder. Basically, the part of the code that takes the everything that was tracked in the state and then builds the aggregated block access list. So from a spec side, this should be okay-ish to do and not like super complex. But of course, we're just talking about removing the read values, and now we are like, okay, let's add some more inputs to the reads. I get the argument that, okay, reads make more sense if we have like this additional 8 bytes, which is like the transaction index attached. But yeah, I would say we just wait for numbers and then we decide upon those things.
One comment about having some data about big blocks. So Nevermind, Kamil from Nevermind with Carlos are doing those some experiments where they have a tool that combines new payloads in from mainnet. They are using from mainnet that combines new payloads into very big new payloads. So they try to aim around 1 gigagas for new payload, for example, but this is more or less configurable. And then they replay those extremely big blocks on the nodes to get some performance metrics from it. So this could be adapted to get even more better, maybe real life numbers, or if you want to check anything there, that sounds like a good idea to get some experience with real like blocks that are around 500 or 1 gigagas.
Okay, yeah, this is interesting. So this is separate from bloatnet, right? Because this might also be something we want to test, like how will everything behave on a bigger.
So currently they were working on mainnet because they wanted to get the, I think, like more mainnet-like numbers, but this could be used on bloatnet too with no problem. But there is a lot of setup because each client has to have a correct snapshot, etc. So it can be rewinded to that point of time. So it's quite manual process, or at least maybe not manual, but there is a lot of manual like preparation in order to automate this process, and it's not really very like easy to just adjust it in on the fly, right?
Right. Yeah. Okay, but this is good to know. Thanks a lot.
I think they will present it somewhere tomorrow about it on some Nevermind related presentation if you want to know more.
Yeah, maybe you can drop the link if possible in the bottom access list breakout channel, or you send it as a DM. Yeah.
Yeah, I can ask them for the link too. Okay, no worries. Dragon, Kita?
Yeah, I'm just commenting on my gut feeling. The block journal and execution journal is not just loading the data, it is some CPU. So having what needs to be read from the database makes sense, because we want, when that CPU happens on 4, 5, 8 threads, whatever we have, we want to have something done in the background. So having what needs to be read, it seems that's going to be impactful. Knowing order what needs to be read, I don't think it's going to be that important. Because even if some thread needs to wait for something to be read, we are not going to be bottlenecked by that much. It's not something that's going to take 100 milliseconds. So there will be a need for mechanisms that will prioritize the reads that are happening now in comparison to all the reads, but I'm not sure if the benefit, it's like, this is just a gut feeling, like my comment. I'm not sure if adding the indices to the reads are going to matter a lot. At least this is how I'm thinking now. Without data, this is just like hypothesis.
Yeah, this makes a lot of sense. And this was also like what I was thinking about, that maybe as long as you can do parallel IO, there's one process busy anyway, and you will just like executing in the meantime. And then you would at least have everything in cache already for the last transactions. And for those first transactions where it would be handy if you have them ready in the cache, you would just do some prioritized IO for exactly that transaction so you can continue executing. But this, yeah, I mean, we need the numbers for that. We desperately need them. But I guess it's, yeah, not so easy to tell, because I also have hard times telling what is the actual efficiency gains we get from parallel IO versus splitting, distributing transactions over threads, and then having this implicit parallel IO too. Or I should better frame it as batch IO versus parallel IO. Because if batch IO is really like super powerful, then it might, and for example, you could imagine like IO would take a fraction of the time that the actual execution takes, then having the indices might not make much sense.
Just additional comment, reading in when you know the data is ordered, at least MDABEX have like the cursor that can, it's faster to read like when you have ordered data. So having batch of all the reads needs to be read with the sorted order is going to be faster than reading it by randomly. I'm not sure by how much. That's like big information here, but I would say 1.5 to 2 times faster.
Awesome, yeah. So what do we think about those numbers that we actually need? So what would be the next steps that what are you guys planning on doing so that we might get those numbers from actual implementations? Would you need anything from, would you need any specific tests, or like you said, with the increased block sizes and that kind of stuff? Like, how would we actually get to those numbers that we would want to have like certainty over adding the state locations, or even adding like transaction indices to the state locations? Yeah, Ben?
I think in the gas testing or maybe the Breakout channel, so Joachim came up with he came up with some tests that were performing quite badly with S-LEDs and S-stores, and it seems they're exactly the tests that what access should address. So we may already have seen some tests. But I'll look into it further.
Have other
we
clients looked into? Yeah, go ahead.
I just wanted to say maybe we need multiple DevNet with different configuration at the same time, and we can see the different performance.
Yeah, of course. This comes, of course, with some overhead that would be nice if we can avoid, like having multiple DevNets with different configurations. I totally get the argument that it's like difficult to simulate it in a vacuum without having actual client implementations running. Yeah, I'm not sure. What do other client teams think about this? Should we actually go for different DevNets, or would it be enough to have like a DevNet that has it implemented, and we measure everything from there.
Maybe not by configuration, but for example, one DevNet with a big state, one DevNet with that it may be a shadow fork of mainnet to see the current performance. Just some kind of configuration like that. And in one, for example, in the blood DevNet, we can have multiple Bezu with different flags. But
Yeah, would it be useful to be able to pass in a flag to turn off any block level access list optimizations, like taking advantage, not doing any preloads, etc., and then not doing any parallelization, and then literally run the same chain, one with the flag on, saying don't do any block level. I mean, obviously you still have to perhaps verify it. And then you'll see this is the effects from the optimizations, you know, parallelization, doing loading state, etc. And here's the effect without them. And we'll see what the uplift is.
Yeah, I would agree. Just a little bit hesitant because of the complexity there. I don't want like clients to have like overly complex implementations on the DevNet. Not sure if this is actually super complex for clients to have like a flag that turns on and off the state locations. Basically, the state locations are always there, but that turns on and off if we actually use the state locations.
Sort of have that for, I think both Nethermind and Rec and maybe some others. So we do caching of precompile results, and in order to measure that for PerfNet and for the benchmarking, we'd have a flag that literally switches off parts of switches off the optimization, so we can get access to the raw underlying, you know, what is the performance of this precompile. So I think it's possible if it would produce worthwhile results.
Maybe a direct question to Jared and Dragan and Kareem. What do you guys think about this?
I don't think it will be difficult to have some flags. We have already some flags. We already started to have different flags with different configuration for block access list in order to be ready for this kind of test. So I don't think it will be difficult to add more flags or to add more configuration.
I'm not exactly sure. What flags are we talking about? Flags that would remove prefetching of the reads? Just that one?
Yeah, exactly.
Okay.
And then the parallelization, I see, if you've done that.
Can you repeat that, Ben?
And any parallelization or so if you're using the S store changes to then use that to parallelize all the transactions. I assume you want to disable
Okay,
that.
removing parallelization of the sections. Okay. Those two flags.
Okay,
cool.
so you can do a this is without block level access, this is with block level access.
Makes sense.
And then, you know, the next day you put gas to 500 anyway.
Have you been looking into this or thinking about this already, Jared? Is there any concerns that you would have regarding adding a flag that turns off prefetching the state location?
Yeah, we can do it. And it should be possible for the transaction parallelization as well. I guess I'm just not fully understanding how the insights gained from the so sorry, my attention kind of trailed off for a bit, but I'm not really understanding how the insights gained from this will help us determine whether the current read format is sufficient or if we need to add the transaction indices. I mean, yeah, I can add flags to disable these various these flags are possible, but it just doesn't. I'm struggling to connect the dots in my head.
Yeah, I think there are two different things. One, we want to know the difference between having the state locations versus don't having the state locations. And for that, a flag that just decides if we use the state locations from the BAL in the prefetcher or not would be enough. Regarding the transaction indices, this will be more complex. And I think we should first focus more on the first, determining if the state locations are worth it. Because if, for example, Dragan's feeling is right that we might not need the transaction indices for the state locations, then we will find that out with only that flag, with only the flag that turns on and off the state locations. If we find out that at a higher gas limit, state locations might be helpful, but only if they actually included the transaction indices, then this is different. But I would assume we can just continue with having this flag that only targets basically what the prefetcher does. Either it runs with the state locations, or you would just run the prefetcher as it runs today.
Yeah, okay. So for us, it would be easy to enable or disable the asynchronous loading of the read locations, but the prefetcher as it runs today is not a thing post BAL for Geth, but yeah, otherwise, okay, yeah.
Okay, yeah, then my fault. I was just assuming that the loading from disk of the state locations would be prefetching, but yeah, sorry for that confusion.
No, it's okay. I just
Awesome.
wanted to clarify.
Yeah, then let me quickly summarize. So we decided today that we talked about SnapSync, that we might keep some BALs around at least to enable SnapSync, and then we also serve them for SnapSync. Regarding the logs, we decided that all client teams put the diffs into the logs so that this makes life of testing team easier. And finally, we also decided that we want to do a DevNet with potentially adding a flag that turns using the state locations on and off in order to give us numbers on how important the state locations actually are. Great. We are already at the end of the call. Is there anything else we should discuss?
I just had a question. Are we talking to add this flag for the next DevNet or another one? Because, for example, in Bezu, we didn't implement it yet, the prefetching from the block access list. So just to see if we need to prioritize that or not.
Yeah, that's a good question. My feeling would be we would probably want to have that on DevNet 1, just because the earlier we get those numbers, the better. For DevNet 0, sorry. Yeah, I would say we should add it for DevNet 0.
I also would like to say that right now we still don't have 3 clients that are consistently working and not forking off. So I still managed to get Nethermind and Geth to fork off, and kind of the prerequisite for us to launch the DevNet properly so that clients can work with a little bit of a transaction load. Especially, I would like to remind everyone to try out the EVM fuzz scenario of the spammer, and see that the client is stable with it. Red seems to be working well, and Bezo seems to be working well so far with it. But otherwise, the other clients are still struggling.
Perfect. Thanks a lot for that update, Stefan. Then I would say is there anything else someone want to bring up? Otherwise, we can take the discussion offline. Awesome. Then thanks everyone, and see you at the next Breakout call in 2 weeks.
Yep. Bye bye.